All right.
Let's go.
6.4 part 2, period 7. Let's go. Monomials. Let's go. Boom.
Good job.
Good job.
All right.
All right.
What? It's in 6.4. It's there. It's right next to the homework. Okay, so on Friday we talked about dividing a monomial by a monomial. We simply divided our coefficients first, our variables next. What was the rule for dividing variables? What do you do with the exponents? Subtract them, nice and simple. Then we did another example. If you stop that. We did another example where we divided this whole polynomial, this whole trinomial by 3x, or by a monomial. And what was the rule there? If the whole thing is being divided by 3x, then each and every term is being divided by 3x. So you just had to separately divide, getting your new trinomial. You're gonna miss stuff. You're gonna miss stuff.
Yeah, you said that last time and you didn't.
I swear, I'm gonna watch it. I swear.
All right, let's not turn this into another stealing of learning time. This is just review, okay? There's no need to copy this down. You were here on Friday, right? And if you weren't here on Friday, you watched the video and took notes, right? Because that's your responsibility. Okay, because I'm just breezing right through these, okay? Then we practiced a little bit. Now we're talking about finding the GCF of a polynomial. Now, remember, what is a GCF?
Greatest common factor.
Good. Greatest common factor. Greatest meaning highest, not greatest like the best. Is that not funny at all? Thank you. Greatest meaning the highest. Common meaning what?
This is like the same.
Same.
Yeah.
And factor meaning
The multiplication. The number.
a number that it can be divided by.
Yes. What she said.
Number, or you can say a number that goes into the product. Number that goes into another number. So we're looking for the highest number that's the same for all the terms that goes into the number. The highest number that goes into the number that's the same as all the other terms. That's your GCF. Now, when you were in 4th grade, it would say, find the GCF of 50 and 110.
Can I do that?
And what would you have to do?
You have to divide them.
No, that's not what you would have to do.
Compare.
Yeah?
Don't you have to find out what number make up 50 and 110?
Yeah, you would have to do your little factor tree.
That's what
I
I meant.
absolutely despise this.
Yes, I know, they are pretty awful. Are you guys okay?
Go ahead his face. Better than ever.
Okay.
No.
He's smart. Just a bruised ego. All right. We would get out our little factor trees. And factor trees are sometimes necessary. Are you bleeding?
No.
Okay. Factor trees are sometimes necessary to find the greatest common factor. I think we need to refocus on this, okay? I'll repeat it for the 3rd time. Factor trees are sometimes necessary to find the greatest common factor because if the numbers are too big to just visualize what the factors are. Like if I said, what's the greatest common factor of 6 and 15? What would you say?
There is none.
3.
Oh,
It's
wait.
3.
Yeah.
The GCF is 3. That's the highest number that they can both go into. What's the GCF of 10 and 30?
10.
10. So sometimes the greatest common factor is just very easy to get because the numbers are pretty low and pretty obvious. But if you have numbers that get bigger, like you will on your homework, you'll have to kind of break them down into 5 times 10, and you stop when you get a prime number. 2 times 5, and you stop when you get a prime number. And then 110, we have, let's say 2 times 55, and then we're gonna stop and get a prime number, and 55 will be 5 times 11. We'll stop when we get a prime number, stop when we get a prime number. So 50 equals 2 times 5 times 5, and then 110 equals 2 times 5 times 11. And whatever prime factors they have in common, you multiply them together to get the GCF. So that's a quick recap of how to find the GCF if your numbers are too big to try to visualize all of their factors. Okay, yes?
So, so say it was like, whatever number it would be, it'd be like 5 times 2 times 3, and then 5 times 5 times
Yeah.
2. Would you only multiply the 5 and the 5 and then the 2 and the 5?
Only the ones that match.
Okay.
So let's say they both had 2 2s and a 5. You would do 2 times 2 times 5.
Do they have to be on top of each other to match?
They don't have to be on top of each other.
They've got to be in the same.
No, you just have to, like, I mean, you can like circle like a 2 over here and then like a 2 over here. But if you write them in order, they're usually either on top of each other or quite close to being right on each other, as long as there's a match. Okay, so that's just a recap of finding GCF in case the numbers are bigger. In this lesson, the numbers are pretty manageable, but I need you guys to know this just in case the numbers are bigger, because on some of your homeworks, on some of the homeworks, they generate bigger numbers that you have to do factor trees for. Okay, so let's go ahead and find the GCF of all of these terms. We're not going to worry about the negative right now. We will talk about negatives in a little bit, okay? So just find the GCF of these terms. That is not this, okay? That's the next example. So finding the GCF is you find the GCF of your coefficients first. What's the GCF of 12, 8, and 6?
2.
2, good. That's the highest number. It's very sad because 2 is such a low number. But it's the highest number that can fit into all of those numbers. And then what is the GCF of x to the 5th, x to the 4th, and x to the 3rd?
X to the 5th.
X to the 3rd. Watch this. X to the 5th, x to the 4th, x to the 3rd.
Oh, I know what you're gonna do.
Are you aware that I keep having to bring my attention to you guys while I'm teaching? Are you aware that it's happened a couple of times? Can this be the last time? Yes, Mrs. Legg. Sorry, Mrs. Legg. Thank you. You don't just look at me like I'm crazy, because I'm not crazy. I have to turn my attention while I'm teaching, okay? So just say, sorry, Mrs. Legg, or yes, ma'am, something like that. Good? Okay. X to the 5th is x times x times x times x times x. 1, 2, 3, 4, 5. X to the 4th is x times x times x times x. 1, 2, 3, 4. X times x times x. 3, 1, 2, 3. We're looking for the highest number of x's that they all have in common. That would be x to the 3rd, right? And the shortcut way to do it, it's so easy, is I know this sounds weird because you're thinking like the highest, the greatest common factor, but the greatest common factor for variables is the lowest exponent, because that's what they'll all have in common. They won't have the highest exponent in common. That'll only belong to that one term. They won't have the middle exponent in common. That'll only belong to the higher two terms. The lowest exponent is the one that represents the highest common factor, greatest common factor. Are you guys good?
You know, it's cool.
X to the third. And that's it. That's how you find the GCF. Now, the next example, we are going to, actually, I might want to stick this in. Yeah, okay, we're gonna go to the triads. Go ahead and do A and B. Do not worry about this negative, just just find the positive GCF. Yeah?
They can't wait to have this kid.
I don't know. Lily, I'd like to see you working okay. Just the GCF of each of those polynomials. Usually they don't give you a tricky one for A, but they did this time. It's a good question. Is anybody wondering what the heck to do for the variable on A?
No, I know what to do.
Carmine, what do you
I
think
think-
you should do?
Just add it to like first.
What?
I just did my solution and then I just did x squared.
It's already
Well-
squared.
All right, Grayson. So you're saying they both terms have x to the first in
Oh,
common?
no. It's, the one that they have in common is X.
To 0.
Really? This one has x to the first? X to the first? Really? You see an x? You see an x there? It's not invisible. X to the 0 would be invisible. X to the first is never invisible.
Because of 0 x.
But there is no x. Yeah.
Oh, I just want to do that.
Oh, okay. Yeah. No, that's what he just said. 18 to the first. Well, what we're asking is what would be the variable portion of this GCF? What? It would stay what? Why are you saying 2?
Squared.
Is it not squared? Am I blind?
Yeah, it's a square.
I have to enjoy this moment because I love how you guys are trying to think so hard, but you're all going into like a very strange direction where you're veering away from the essential definition of the greatest common factor. Whatever is the greatest common factor has to be the same in both. It has to be the highest number. Thank you. She got it. Do I have any left? Sorry, Char. How about a swaggy tag?
Yes, swaggy tag.
Yeah?
I just put myself in the rest.
How about a swaggy tag?
How about this one you said?
Alright, well, I don't know when I'm gonna drop it.
You should get.
Then you can watch on video. You should do all your things.
It's like,
You lied.
Make sure you put your name on it. Okay.
can you see
Char
this?
Char is correct. Why is it talking? Why is it talking? You guys think this is your class? Thought it was mine. Char Char is correct. The greatest common factor of 15 and 18 is what?
3.
3. The greatest common factor of x squared and nothing is
Nothing.
nothing.
So it's just three.
Just 3.
Just t.
Can I try to?
And this is where we have to just be okay with the fact that sometimes there might not be a common factor.
What?
There is no common factor of x squared and nothing. Okay?
That's not nice.
So, anybody get this?
Yes.
Yeah.
I got 6
Okay.
y
Yeah.
squared.
That's correct. 6y squared is correct. 6 is the GCF of 18, 6, and 24. And y squared is the GCF of the variables because it's the lowest exponent of all 3. What?
I'm not.
Oh, you're thinking like 2 can't go into 3? Now remember, exponents are not,
It's a 5.
are not actual number values. They're representing how many y's are being multiplied. It's almost like a label. It's representing y cubed is representing y times y times y. It's not actually, there's no 3 there, it's just saying how many y's. It's like a short way to write it. Yeah,
I like get the entire lesson now. Now that I've read that.
you got it? All right.
I like
No.
It's like, I'm good.
Okay. Now, we're gonna, oh, you know what? I'm gonna go back to the other example that we already worked with, this one. And now we're going to say factor out the GCF. On your homework, it might just say factor this. So if it says factor out the GCF or just factor this, means the same thing. Did you guys hear what I said? The book homework questions like to say things in various different ways to drive us insane, and to also make sure you will be able to interpret several different types of questions, all meaning the same thing. So this trinomial, we already found the GCF of it, which was 2. GCF was 2x cubed. When we factor this, what we're doing is we're breaking this up into factors. Well, the GCF is one of those factors. It's the greatest common factor. I need everybody to focus up here, okay? I see a lot of like drifting focuses. Okay, so if I am going to factor this or factor out the GCF, the greatest common factor, is one of those factors. So I'm gonna need the GCF as one of the factors, and then the other factor I'm gonna call the rest. How do we get the rest? Yes?
Divide each term by the GCF.
Divide each of the terms by the GCF. So once we get our GCF, 2x cubed, then we take each of these terms, divide by our GCF, 2x cubed, and that will give us the terms inside of the other factor. What's 12 divided by 2?
6.
X to the fifth divided by x to the third.
X to the second.
Yep. X to the fourth divided by x to the third. Oh, whoops. 8 over 2.
4.
So plus 4, and then
Just X.
just x, and then
3. I mean, yeah, 3.
minus 6 over 2,
Minus 3.
minus 3, and then x to the
Nothing.
third over x to the third is gone
Well,
because
X is 0.
it's not 0, it's x to the third over x to the third is 1. 3 times 1 is 3, or I should say negative 3 times 1 is negative 3. So it doesn't change anything, so we're not going to put anything there because it canceled itself out. And this is your final answer. Somebody in my other class said, do you have to distribute? And I said, sure, let's distribute. Let's go ahead
Yeah,
and
but
distribute the
what-
heck, but what's gonna happen?
It's gonna end up like that one.
We're gonna get this one. Exactly. So,
Distribute.
what?
So you don't distribute.
No, you don't.
She's like, so we're not gonna distribute, you said to distribute. Sure, you wanna distribute? Let's distribute. 2 times 6 is 12. X cubed times x squared is x to the fifth. 2 times 4 is 8. X cubed times x is x to the fourth. And then 2 times negative 3 is negative 6, and then we have x cubed. Okay, look at that. When I distributed, I ended up with my original trinomial.
Yeah.
So basically, distributing is a really good way to check your answer, to make sure you factored it correctly. If you factored it correctly and you distribute, you should go back to the original question. That make sense? So at this point, you guys can copy down these steps. Steps to factor out the GCF or simply put, steps to factor. Now, we did not get to the star yet. You can copy it down, but we did not get to a problem where we have to factor out the negative. It's very simple. Go ahead.
I got that one on my homework. It was difficult.
Yes. Did you get all the stuff down? You wrote all the steps?
I wrote stuff.
Oh, I did.
Can you write the steps and then you can go to the restroom?
Yeah.
Last night.
Video.
I did, yeah, for advanced class. Yeah, I'm sorry.
Make what?
You sure?
Yeah, today I'm actually gonna be really
We should make sure to say Mrs. Legos here.
What does he?
Of course. Aren't you just the best note taker in
What? Okay.
Wait, Bo, what are you doing?
Did you get everything now?
What are you doing? Huh?
I'm doing math.
Wait, you're doing the homework?
How much?
Carmine, is he doing the homework? No.
Yeah, you're right now.
All right, so now we're going to do an example where we're going to factor out the negative. Did we do that yet? Yeah, we did. Okay.
Yeah.
Now we're going to factor out the negative. We're going to... May I continue? Without the noise. You're going to miss this though, Angus.
I'll let you watch the video.
So, the times when you want to factor out the negative is when your starting term is negative. We don't like negative starting terms. It just sets a bad tone. It's got a negative attitude. But don't put it in the basement. We're just going to factor it out. So, when you factor
Reverse psychology.
this, you're going to pull out the GCF and you're going to pull out this negative with the GCF. And it is factoring it out because what's going to happen is factoring out that negative. Okay, so let's go ahead and first factor out the GCF. So what's the GCF of 12, 18, and 27?
Oh, gosh. 3?
3. What's the GCF of x cubed, x squared, and x?
X.
Good. X is correct. Who said that?
Me.
Oh, very good.
Thank you.
Now, if we factor out the negative with the GCF, all that's going to do is allow us to cancel out this negative because we're going to divide. Remember, to get the rest here, we have to divide each term by the GCF. So if I'm factoring out the negative as part of the GCF, I'm going to divide each term by negative 3x, negative 3x, negative 3x. So what's going to happen to all of these signs?
Reverse.
Yeah, they're going to negate. That's what negative, negate. It's going to negate all these signs. So this one will become positive, this one will become negative, and this one will be positive. And we can distribute in the end and just show that it works. So what's negative 12 divided by negative 3?
Negative 4? Or no, 4.
4.
Positive 4, good. And then x cubed over x,
X squared.
x squared. And then positive 18 over negative 3.
Negative 6.
Good. Negative 6. X squared over x.
X.
Good. And then negative 27 over negative 3.
Positive 9.
Positive 9. X over x.
Nothing.
Gone. Yeah. Just careful, there's a tiny tripod. Okay, so this is the final answer. But you can distribute to double check. So negative 3 times 4. Guys, you gotta go faster than this. Negative 12. X times x squared. X to the third. Negative 3 times negative 6
18 x's.
plus 18, x times x is x to the second. And then negative 3 times 9 minus 27, and then x is just x. Does it match?
Yeah.
So that's the.
Yep.
So that's just like the checking.
That's just a check, because this isn't the answer, because that was the question. This is the answer. We just use the distributive property to check it. Just so you guys know, number 9 on the homework is very tricky. Most of you will probably have no idea what to do. Don't worry, I have a homework help video, and it's the last 5 minutes of the video. If you need help with it, you can scroll. I'm gonna allow you guys to start your homework.
Thank you.
I highly recommend starting with the last couple of questions, like maybe 6, 7, 8, and 9, because that will be from this lesson.
How many questions are there?
9.
Okay.
That's why I said the last